Greetings to Muhammad Yusuf. The reason I'm here is to like to present about the BMM 3521 Fluid Mechanics Lab. So this is our fourth lab, which is determination of pump performance with different configuration. These are the group members. Our group members consists of 4 members. I myself, Kogulan Lakimaniam, MA18098, would like to start the presentation. First and foremost, I would like to talk about the introduction, which is chapter 1. In general, a pump may be defined as a mechanical device which, interposed in a pipeline, converts the mechanical energy supply to it from same external source into hydraulic energy, thus resulting the flow of liquid from lower potential to higher potential. Next is the objective. These are 3 objectives in this experiment. First is to design complete measurement technique for fluid flow and determine the pump performance with single pump, series and parallel pump configurations. Then second is to investigate the relationship between pressure head, flow rate, power consumed and efficiency for a pump. And third one is to compare the performance curves of different pumps. And then the theory. So this is the theory. So I would like to say for the series pump pressures are added together by the volumetric flow remains the same. This is the simplified term for the series pump. So where the P total equals to P1 plus P2 and Q total equals to Q1 equals to Q2. Then I would like to touch about the parallel pump. Therefore, for pumps connected in parallel, the volumetric flows of the pumps are added together. The achievable pump pressure remains the same. So as you can see, the delta P total equals to delta P1 equals to delta P2 and Q total equals to Q1 plus Q2. So this is the equation, the formula that I'm going to use. First is the total power P of the pump results from the volumetric flow Q and the achieved pressure difference between the delivery and intake sides of the pump. So power P equals to delta P multiply with Q. The input power is electrical, which is P in. The output power is P out. Is dependent on the pump efficiency. So the efficiency is equals to P out equals to over P in, where P out equals to rho GH times Q, where P in equals to omega T. We can derive as omega equals to 2 pi n over 60 times T. So that's all from me. So I would like let my colleague to speak. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Nauf bin Isa and my ID is MA17222, and today I will be talking about chapter 3, method and procedure. Okay, first you can see the apparatus involved in this experiment and the components in the apparatus itself. One is the pump, 2 is the manual valve used to switch from parallel to series, 3 is the manometers to read the data, and number 4 is the water tank, which supplies water to the whole apparatus. Okay, next is procedure. So the first one is set up the multi-pump test rig and double check that all the components are in good working order so that the data collection process is not disrupted. Number 2, switch on both the unit and the pump. Number 3, fill the tank with water and keep it at the same level. Number 4, when the pump is turned on, make sure the water level does not fully drop or is zero. This is to keep the pump from going bad or destroying itself. Number 5, adjust the pipe configuration as required for the connection. The valve has been programmed to use a single pump configuration for now. Next, number 6 is gather information from the sensor installed to the pump. The flow sensor detects the reading in the voltage form, which is the converter into frequency. The pressure in the pipe flow relation is detected using a strain gauge sensor. Number 7, if there is an error in the data reading from the sensor, calibration is needed. And finally, the experiment is replicated for various connections, including series and parallel pump configuration. Okay, so for the precaution, the flow rate meter's mean value should be used because it shows fluctuating readings as the fluid is flowing. Second, the entire piping system is considered tight with no flow rate loss. And 3, when taking readings from the measurement instruments, avoid parallax error. And finally, after the experiment is completed, remember to hold the delivery valve open and switch off the mains. That is all from me. Thank you very much.
So next we go on the chapter 4, which is result graph and discussion. This is the result for the three configuration. For the first one is the single pump configuration, which we can see at the left side. For the right side is the series pump configuration, and the last one is the result for parallel pump configuration. So this is the calculation how we get the water horsepower, efficiency and net head. For the single pump configuration, we can see H equals to PD over rho G, which is the formula P out equals to rho GHQ, and the efficiency is P out over P in times 100%. For the series pump configuration, the formula is the same, but for the H, we total the H1 and H2, which is pump 1 and pump 2. This calculation is also same for the parallel pump configuration. Next one is the graph. This is the graph that we get from the result, which is the net head versus volume flow rate for the three configuration. As we can see, the red line is the single pump configuration, the yellow line is for series, and the orange line for the parallel pump configuration. The last one is discussion. From the experiment, characteristics of pump ran at different conditions are observed and drawn in graphs. These attributes curves are critically in determining a pump's features, as size and shape alone cannot be used to pick a pump for a certain application. Standard tests were carried out according to the lab manuals method, and characteristic curves were created. According to the table and graph above, the parallel pump produces the high head, followed by the single pump and the series pump. The highest head will theoretically be obtained by using a series pump. Each pump in series will add head to the system without increasing flow. In parallel pump operation, the flow of both pumps is combined to generate a new curve, increasing the flow rate. Following that, we discover that parallel pump is most efficient, followed by series pump and single pump. This is in theory correct. The tests were complete correctly. However, the result were tainted by some human or computer error.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Iqbal bin Muhammad Ali. Okay, for the conclusion, as a result of our experiment, we have gained knowledge on the effect of pressure drop, pump power, and efficiency of various pump configurations. In the experiment, we designed and set up a single, series, and parallel pump arrangement. High head can be delivered by a single pump setup. A series identical pump on the other hand will produce double head of single pump at the same flow rate. A parallel pump design is utilized to deliver a larger flow rate. Okay, that's all from me. Thank you.